Greetings. Today we'll be talking about how to synchronize generators. We'll also be touching on these objectives. Importance of synchronizing generators. Why we need to synchronize generators. Common faults in synchronizing generators. The effects of improper synchronization of generators. Safety features and devices for synchronizing generators. Please take note. It is important and common knowledge for all marine engineers to know how to synchronize generators.
The three important parameters that the incoming generator has to fulfill before we can close the main breaker.
The voltage must be equal or slightly higher than the bus bar. The frequency should be equal or slightly higher than the bus bar. The phase angle of the incoming machine should have a phase angle of 0 or equal magnitude. To facilitate this operation, a synchroscope is always provided. Now, in the event of a failure, we can always use the synchro lamps to help in the synchronization process. In practice, the rotation of the pointer should always be in the fast direction, and the closing of the breaker is normally done when the pointer is at 11 o'clock. In this way, the incoming machine with a slightly faster rotation will immediately assume a load.
I've heard about my friends talked about the objective, operation, and the requirement to synchronize two generators. Now, before we go to the safety devices and features, I will explain about the theory of synchronization.
Before I explain and show you the theory of synchronization, let me revise the three requirements to be fulfilled before we synchronize a generator. The incoming generator should have the same voltage, the same frequency, and the same phase sequence. We have two generators. First is the running generator that is already supplying to the bus bar, and the second one is the incoming generator which we are about to connect to the bus bar. Then we have two sets of voltmeter. One is connected to the bus bar, and the second one is connected to the incoming generator before the breaker. Also, we have two sets of frequency meter. One that is connected to the bus bar and another to the incoming generator. Observe the connection of the phase angle synchronize indicator. We have two types of phase angle synchronized indicator. First, we have the traditional pointer type synchroscope, which is this one. Second, we have synchroscope indicator that use a circular set of LEDs, this one. Again, observe the LED lamp wiring connection. Then observe how the pointer type synchroscope wiring is connected on the diagram. Alright, let's go to the next slide. An example of phase angle between two generators during synchronization. Before we look at the phase angle, I would like to ask you a question. How do we know when is the right time to close the breaker in order to achieve this condition? It's easy to say that recommendation to close the breaker when the needle is pointing at 11 o'clock clockwise direction if you are referring to pointer type synchroscope indicator. On the other hand, if you are referring to the LED's lamp type synchroscope indicator, you have to see that the lamp connected RR is dim and BY and YB is light up. And on the diagram, we have the governor control. One is to lower down the governor, and the other one is to increase the governor speed. Let's start the animation. You can see that the incoming generator output voltage is moving really fast. Can you synchronize the generator in this condition? Remember, you have to make sure that for the pointer type synchroscope indicator, it must be at 11 o'clock for you to synchronize. And also, if you are referring to the LED lamp type synchroscope indicator, you have to make sure that RR LED is dim, BY and YB is light up. Now, when it's moving too fast, what you should do is to lower down the speed. Let's click on the low button of the governor to lower down the speed. By referring to this animation, you could see that the animation is slowed down. But still, is it possible for you to close the breaker at 11 o'clock? It is still impossible. So why not we lower down again the governor? The movement of the output voltage of the incoming generator is slowed down again. But it is still impossible for you to close the breaker at 11 o'clock or when the LED lamp type synchroscope indicator is in the proper condition for you to close the breaker. Now, let's lower down again the governor. And right now, it is slow enough for you to close the breaker. Now, what happened when we close the breaker at 11 o'clock? There you go. It's already running in parallel.
Naturally, there will be some safety devices fitted to protect the generator in the event of incorrect synchronization.
Where parallel operation is intended for 2 or more AC generators, safety requirements have to be followed. Below are some of the normal instrumentations and devices fitted on a main switchboard. Reverse power relay. If a prime mover failure occurred, the generator would act as a motor. The reverse power relay detects this fault and acts to trip the generator circuit breaker. Under voltage trip. This protection is to prevent closing of the circuit breaker when the incoming generator's voltage is less than 70%. Additionally, this is also a backup to short circuit protection. Overcurrent. This instantaneous tripping protects against extremely high overcurrent caused by a short circuit fault. Under or over frequency. Under and over frequency settings are typically 58 and 62 Hz for a 60 Hz system. These devices are fitted for the protection of the AC generators.
We have now come to an end of this program.
In a nutshell, synchronizing generators is an important common knowledge.
If you have any doubts, feel free to replay the video.
Thank you for watching.